So now moving on to the second part of this section, and this is the last part of the section before we have our first assessment on this, and it's going to be solving and graphing multi-step linear inequalities. So you see it's very similar to what we're doing in the beginning of the year with solving equations, but now we're looking at it as inequalities. And your objective for today is you'll know how to solve and graph multi-step linear inequalities. So we're not going to go through every single type of multi-step inequality here. We're going to go through some of them. But everything that we did with equations holds true for this as well. We still solve them just like we normally would as if it was an equation. But at the end, we need to graph it and represent that it's not just one solution we're getting, but it's actually a range of solutions that we have. All right. So nothing changes as far as the steps that we do, except for when we have a negative number that we're dividing or multiplying by, we do need to remember to flip our inequality, which we didn't have to do that for an equation because even if you flipped your equation, it's still an equal sign. All right, so let's go ahead. We're just going to do a couple examples for this video and then be done with this. All right, so the first problem we're going to do is 5x plus 22 is less than or equal to 12. All right, so we're going to solve this as if it was an equation. So what is being done to it? Well, we are multiplying and we're adding. So remember, in our PEMDAS, we need to go in the reverse order. So that means that we need to get rid of the addition first and then our multiplication second. So to get rid of addition, we need to subtract. So remember, even though this we're subtracting and it's minus 22, when we're adding or subtracting, we do not flip our inequalities. It's only when we're multiplying or dividing. So after we subtract 22 from both sides, we get 5x is less than or equal to negative 10. Same thing. Just because this answer changed to negative doesn't mean we flip our inequality. It's only when we are multiplying or dividing by a negative number. So now we did our addition. Now we get rid of our multiplication, and we do that through division. And we're dividing both sides by a positive 5, so nothing needs to flip. Negative 10 divided by 5 is negative 2. Now that we isolated our inequality, now we can start to graph. The mistake that a lot of kids will make is they'll start with this number here, 12, and try to plot that. It's not what we begin with, it's what we end with. It's our solution that we are graphing. So now I'm going to go negative 2. I'm going to put that in the middle of my number line. So you see now I have a smaller number line. And this is what it'll probably be on your test. So I'm filling that in. It's equal to, so I know it's going to be a colored in circle. So at negative 2, I'll put a colored in circle. That separates my graph into two different regions. Since I'm just multiplying, it doesn't matter which numbers I'm going to pick. So I'm going to pick 0 and I'll pick negative 3. I'm going to plug them in. 5 times 0 plus 22, is this less than or equal to 12? Well, 5 times 0 is 0, so now we have 22, and 22 is not less than or equal to 12, so we know that this side does not work. Now I'm going to plug in the other point. So now we have 5 times negative 3 plus 22, is this less than or equal to 12? Well, 5 times negative 3 is negative 15, and negative 15 plus 22 is equal to 7, and 7 is less than or equal to 12. So this region does work. So that means that my graph will need to go to the left where that region was, and there is my solution. So my solving my inequality is x is less than or equal to negative 2, and my graphing it is below. You will always graph all the answers you get on your assessment, so make sure you are practicing how to graph. All right, so the next problem we have here is 3 times 2x minus 6 is less than negative 4 times 2 minus x. So once again, this was a problem that you would have been given for equation, and I do expect that you guys can answer this. So we're going to go through it and simplify both sides of our inequality first. So since we have this multiplication, I'm going to simplify by distributing that 3 in. And 3 times 2x is 6x. 3 times negative 6 is minus 18, and that is less than. So now the thing here, we're not multiplying both sides by this negative 4. We are just simplifying the one side that we have. So we are not flipping our inequality because you must multiply both sides by the same number. All right, so in this case, we're not doing that. We're only simplifying the one side, so it will not flip our inequality. So then we will do negative 4 times 2, which is negative 8, and negative 4 times negative x, which is then positive 4x. And now, just like we would have before, we need to bring all of our variables to one side of our equation. Well, now it's one side of our inequality. So that means since I don't want to have to flip my inequality, and when you're graphing, if you're reading your inequality, you would read it left to right. I'm always going to be in a habit of moving my variables to the left. So I'm going to subtract my 4x from both sides. And remember, subtraction, you do not need to change anything. So that just cancels out. So 6x minus 4x gives me 2x. Minus 18 is now less than negative 8. Then I need to get this x all by itself. So I'm going to add 18 to both sides. And then I'm going to write it over here because I'm running out of space. So then I get 2x is less than 10. And now I'm going to divide each side by 2, so x is then less than 5. So I'm going to fill in my number line, 5, 6, 7, 8, 4, 3, and 2. It is just less than, so that means it is going to be an open circle. So I'll go to 5 and put my open circle. It creates 2 different regions now. And I'm going to pick 2 different points. Since it doesn't matter because we're not dividing, I'm just going to go ahead and pick 6 and 4. And I'm going to plug them in. So 3 times 2 times 6 minus 6, is this less than negative 4 times 2 minus 6? All right, so now I'm going to ask the question. So 2 times 6 is 12. So 3 times 12 minus 6. Well, 12 minus 6 is 6. So 3 times 6 is equal to 18. And I'm asking, is this less than? So 2 minus 6 is negative 4. So negative 4 times negative 4 is equal to positive 16. And 18 is not less than 16. So that is not a solution. So we know that that side does not work. Then I'm going to go ahead and plug in my 4. So 3 times 2 times 4 minus 6. Is this less than negative 4 times 2 minus 4? Well, 2 times 4 is 8. So 3 times 8 minus 6. 8 minus 6 is 2. So 3 times 2 is 6. And is this less than? Well, negative 4, 2 minus 4 is negative 2. And negative 4 times negative 2 is a positive 8. So 6 is less than 8. So that means that this side worked. So my graph needs to go into that region. All right, remember, plugging these points in is going to be something that's really, really important that we do later on when we're graphing with 2 variables. So it's important to get into this habit. All right, so now we're just going to go through some special cases. And remember, when we're learning equations, there's things that happen that either told us infinitely many solutions or no solutions. And there are things that can tell us special cases for inequalities as well. And we're going to go through those now. All right, so here we have the problem of 12x minus 2 minus 2x is less than or equal to 7 plus 10x. So same thing. When we're solving our equations, we needed to simplify each side of our equation as much as we could, and we do that for inequalities as well. So the first thing I'm going to do is combine my like terms of 12x minus 2x. Since they're on the same side of the inequality, I'm not moving it to the other side, I can just add or subtract them. And 12 minus 2 gives me 10, so now it's 10x minus 2 is less than or equal to 7 plus 10x. All right, so now something should maybe start jumping out at you. But I'm going to move my variables to one side, and I always like moving my variables to the left, so I'm going to subtract 10x from both sides. When I do this, they cancel out on both sides and give me a 0. And now I'm left with the statement of negative 2 is less than or equal to 7. Just like before, is this a true or a false statement when our variables completely disappear? And this is a true statement, right? Negative 2 is less than or equal to 7. And since this is a true statement, this means that all real numbers will work. All right, any number from negative infinity to positive infinity will work if we plug this in. All right, so if we get a true statement, just like we did with equations, then we said infinitely many solutions. Here we will say all real numbers. All right, and then we're going to go through one more example where it doesn't work. All right, so now for this example, same thing. We need to simplify both sides of our inequality. So that means I'm going to have to distribute this 4 in. So I get 8x minus 3 is greater than 8x plus 12. So I'm going to now start isolating my variables. And since I have them on both sides, I need to move them to one side of my inequality. So I'm going to move the 8x to the left. By doing that, in this case, both of them cancel out. And now I'm just left with the statement negative 3 is greater than 12. Well, is this a true or a false statement? This is a false statement. Negative 3 is not greater than 12, so that means that there is no solution. All right, so you see everything that we're doing in the beginning of the year is coming back now. The only difference is now we're dealing with an inequality, but nothing changes as far as how we solve it, the steps that we took. It's just now with inequalities, if we're multiplying or dividing by a negative number, we need to flip our inequality. And now it gives us a range of solutions instead of just one, which means we're also going to have to graph these as well. All right, that is it for this video.